Okay, let's have a look at this one. Aha, now, these are getting hard now. Okay, this is just telling us what's on the diagram already. Okay, and this is saying calculate the length of BC. BC, so it's this length here, so I'll call that one X. Now this is about similar triangles. Now if you remember, similar triangles have the same angles. So if two shapes are similar, they have the same angles, but the lengths, yeah, have a scale factor. Yeah. So with this one, first of all, we need to prove that these are similar triangles before we go any further. So let's have a look. We've got this one here. This is nice because obviously those two must be the same because they are opposite angles. They are opposite angles, so those two are the same. If we look at this angle here and this angle here, we can see that we've got a Z there. So these are what we call alternate angles. So we can say that those are the same as each other, and it also then stands to reason that this one here must be the same as this one because again you've got another Z there, haven't you? So this one here is the same as that one there. Now, so we prove that they are similar. Now we've got to work out what the scale factor is. Now if you look at these two sides here, these sides correspond to each other, don't they, on the two shapes. So we can say that sixths multiplied by the scale factor is 9. 6 multiplied by the scale factor, whatever it is 9. And if we divide both of these sides of the equation by 6, we end up with the scale factor must be 9 divided by 6, which is 1.5. Okay, so we know that the scale factor is 1.5. Now if we look at this length here corresponds to this one here, don't it? We're going from the red angle here, the blue angle here to the red angle. And we're going from the red angle to the blue angle there. So these two sides correspond to each other. So we can say then that this angle here, okay, or this side here, okay, BC, will equal 5.2 times the scale factor, which we now know is 1.5, don't we? So it'll be 5.2 times 1.5, which I make out to be 7.8. So that equals 7.8 centimetres. Now, if we look a bit further, so that goes in there. And the next question is calculate the length of CE. CE. Let's have a look at CE. CE, that's this side here. I'm going to call that Y. Okay. Now this side corresponds to this one. So we can say then that Y times the scale factor equals 7.2. So we can say then that Y must be 7.2 divided by the scale factor. Okay, which is 7.2 divided by 1.5. 7.2 divided by 1.5 gives me 4.8. 4.8 centimetres. Okay, so I shall put that one in there. Okay. Next one. Ooh, right, so we've got some algebraic fractions here, haven't we? Now, the way I always think of these is that, you know, we don't like things on the bottom. We don't like working fractions, so let's get rid of these two. Let's get rid of them. Okay. So I'm going to multiply everything by 4 to start with. So I'm going to multiply this one by 4. I'm going to multiply this term here by 4. And I'm going to multiply this by 4 as well. So we end up with, in this case, we'll get these two will cancel out, won't they? So we'll end up with 2x minus 1 equals, sorry. Let's just get that right, make that right. 2x minus 1, okay, here, plus 4 times this, so that's 4 times x minus 1 over 5. equals 2 times 4, which is 8. Right. Now I want to, I think I'll put brackets around here for the moment, just so it doesn't confuse things. And now I'm going to times everything by 5 to get rid of this one. So I'm going to multiply this by 5, I'm going to multiply this by 5, and I'm going to multiply this by 5. If I do that, I get 5 times 2x minus 1 plus, well, those two will cancel and you'll be left with 4 times x minus 1 equals 40. Okay. The next thing to do is to multiply out the bracket. So that's that times that, and that times that there, and that times that, and that times that. Okay. So we're going to get 5 times 2x is 10x. 5 times minus 1 is minus 5. Just watch your negative numbers. 4 times x is 4x. And 4 times minus 1 is minus 4. And that equals 40. Okay. Now we can add like terms. So looking at it, I can see that we've got 2x terms there. So we should be able to group those together. And we've got two numbers here. Okay, so we should be able to simplify that. 10x plus 4x is 14x. Minus 5, minus 4, well that's just number line. You're at minus 5, and you're going to take another 4 away. So that's minus 9 equals 40. Okay, so now we've got a much simpler problem. And I'm going to add 9 to both sides to get rid of that 9. So we get 14x equals 49. And then I'm going to divide by, finally going to divide by 14. So we get x equals, it's going to be 3.5, isn't it? 3.5. Okay, just use your calculator for that last bit. Okay, x equals 3.5. Okay. Next question, number 14. Oh, this is bounds of measurement. Y is 1.8 correct to 1 decimal place. So it's been rounded to 1.8 and we're trying to find out what the lowest possible bound is for this. Okay, but first of all we need to find out what the lowest possible value of y could be. Okay, what the lower limit is. Okay, so we do this like this. We get, we put our 1.8 there. And we say, what's the smallest that this could have been before it was rounded to 1.8? Okay, it's correct to 1 decimal place. Okay, so that means that we need to go to 2 decimal places. And this is going to be 1.75, isn't it? 1.75. That's the smallest value that will round to 1.8. Okay. And because we've taken off 0.05 here, we need to add 0.05 to get to the other, because they always have to be the same distance apart. So we're going to get 18 at 1.85 here, 1.85. Okay, so this is the smallest possible value it could have been before it was rounded, and this is the largest value it could have been before it was rounded. Okay, now we've done that, we can hopefully answer this question. Calculate the lower bound for this, which means we've got to use the lowest possible value of y, haven't we? So we substitute this value here into that equation. So we've got 4 times 1.75 plus 1. Okay. Well, 4 times 1.75 is 7. Okay, this is 7. 7 plus 1 is 8. So the answer is 8. Okay, if they'd asked you for the largest value, largest possible value, you would have put this one in. Okay.